Okay, folks, let's have a look at trig equations and graphs together, okay, which is the next step for the work that we've been doing with trig equations. Okay, now, just as I kind of to preface what we're about to do, let's have a wee reminder of some work from trig graphs in National 5. You can take this down if you feel that you need to. Okay, now, if I had something like that, and I said that was a sine curve, and it was of the form a sine bx goes up to 5 down to minus 5. Let's say that was 180. Okay, so a is the amplitude, that's the total vertical height halved, so up to 5 down to minus 5, that's 10, half that, and I get 5. Okay, how many curves, full curves I've got in 360? Well, there's 1, there's 2 and 180, so that would be 4, so that would be 5 sine 4x. Okay, let's say we had something that looked like that. And I said that that was a cosine curve this time, y equals a cos bx. Okay, and it goes up to 7 and down to minus 7. Okay, so that would be 14, half it, and you get 7, so that would be 7 cos, how many curves in 360? 1, 2, 3, 7 cos 3x. Okay, so that's just a wee quick reminder of the kind of work that you did. Quite simple. Identifying different features of a sine curve and a cosine curve, and you did do a tan curve at National 5 as well. Okay, now let's just kind of put that into play with what we're about to look at next, which is to take the work that we've done with trig equations in part 5, which was the last video, using the double angle stuff, but putting it into some diagrams and seeing if we can solve some problems from there. Okay, so let's take down example 1. We're going to find the coordinates of the points of intersection of the following curves. Okay, so the first one, what I'm going to say is that that is a sine curve, and it's of the form a sine bx, and I need to find out what the equation of that curve is. Okay, it gets up to 3 and down to minus 3, and I've also got this one. Okay, now what I'm going to say is that it's a cosine curve, and it's of the form y equals a plus b cos cx. Okay, right, let's first of all identify the features of the curve. Okay, we've got the sine curve. Now it goes up to 3 down to minus 3, so it's got a maximum, it's got a total vertical height rather of 6, half that to get 3. And how many curves have I got in 360? Well, it's just one complete curve in 360, so it's going to be 3 sine 1x, so just 3 sine x. Okay, with this one, it's 2. Got a total vertical height of 2, half that to get 1, so it would be 1 cos, got 1, 2 complete curves, 1 cos 2x. Now, That means it should go up to 1, however it's been adjusted, it's been moved up by 1 unit. So it's 1 plus 1 cos 2x. And I can just shorten that down to 1 plus cos 2x. Now, to find the y coordinates then, that's these points of intersection. Now remember that the work to identify that stuff, right, that's National 5 work, okay? There are videos on the Rossall Maths Department channel. If you look for trig graphs at National 5 level, you should find some stuff, okay? So we're not going to concentrate on that just now. What we are going to concentrate on is the higher content, okay? Now, what we do know is that these are points of intersection of these two curves, okay? Now, what can you say about the points of intersection? What you can say is that the y coordinates are equal, so what we can do is we can make y equal to y, and that is a familiar statement to make across a lot of different topics in higher maths. So we're going to make y equal to y. So we're making y the cosine curve, 1 plus cos 2x equal to y the sine curve, 3 sin x. So now what we've got then is 1 plus cos 2x is equal to 3 sin x. Okay, so my next move then is to bring the thing across, make it equal to 0, so bring that over. I've now got 1 plus cos 2x minus 3 sin x is equal to 0. Now that's now a double angle trig equation, so what I need to do then is use one of my double angle equations. So it's either going to be 2 cos squared x minus 1, or 1 minus 2 sin squared x, and the one that's hardly ever used, I'm going to write it down though, is cos squared x minus sin squared x. Okay, so it's a choice really between this one and this one. Now, the advice that I gave in a previous video was if you've got cos 2x and sin x also appears in the question, then you use 1 minus 2 sin squared x. So that's the one that we're going to use. Okay. So where I see cos 2x, it's a straight swap, and that's a swap, right? So 1 plus 1 minus 2 sin squared x minus 3 sin x is equal to 0. Let's tidy that up now. We've got minus 2 sin squared x minus 3 sin x plus 2 is equal to 0. Now see, at that point, what we should do is make life dead easy for ourselves. Easier. Multiply through by minus 1 to get 2 sin squared x plus 3 sin x minus 2 is equal to 0. What I'm going to do now is recall some of the work in previous videos and previous lessons. I'm going to liken 2 sin squared x plus 3 sin x minus 2 equals 0 to 2x squared plus 3x minus 2 equals 0. Okay, 2 multiplied by minus 2 is minus 4. Two numbers multiplied give minus 4. Add together to give 3 is plus 4 and minus 1. 4 times minus 1 is minus 4. 4 minus 1 is 3. So that's plus 4 minus 1. Drop 2x in here, drop 2x in here. First bracket I can factorise further, take out a common factor of 2 down to x plus 2. Second bracket is still 2x minus 1, that's equal to 0. Okay, let's bring it back in. X plus 2 sin x plus 2. 2x minus 1, 2 sin x minus 1. Okay, next move. Line down the page. sine x plus 2 equals 0, 2 sine x minus 1 equals 0. Bring that across, sine x equals minus 2, x equals sine inverse minus 2. Now with or without a calculator? With a calculator I'm going to get a maths error. Even if I don't have a calculator, alarm bell should be ringing at that point, because the sine curve, sine x, can only go up to 1 and down to minus 1. It certainly doesn't go down to minus 2. So what I'm going to say at that point is discard that and just say no solutions. You can get those kind of errant results coming up with trig equations and you just discard it, but make a remark, communicate to the marker that there are no solutions and that you're aware of that. Okay, over on the other side, 2 sine x equals 1, sine x equals 1 over 2. Okay, so that means we are in the all quadrant and the sine quadrant. Okay, so my exact value then for when sine equal to 1/2, 30 degrees, that's my all quadrant solution. Look at the sine quadrant, that's going to be 180 take away 30, that's 150 degrees. Okay, so that's my solutions. Now if I go back to the question says find the points of intersection, right? Not the x coordinates, the points of intersection. Now what's a point got? A point has got an x coordinate and the y coordinate. Now I've got my x coordinates, I now need to find my y coordinates. Now how do I do that? I need to put x back into y, just like you would do, for example, in differentiation with stationary point questions. If you want the y coordinate, put the x coordinate back into y, same thing. So where do I find y? Well, you've got two equations for y. So you just pick one and put it in. So one of my equations was y equals c3 sine x. So what I'm going to do then is sub in x equals 30. I could use the other one, which is y equals 1 plus cos 2x, that would be fine as well. Just choose one, there you go. Sub x equals 30 into y. So that's going to be y equals 3 sine 30. Now, sine 30 is one of your exact values. And what's that again? That's 1/2, so that's 3 times 1/2. 3 over 2. So point of intersection 1 then is, well, the x coordinate is 30 degrees and the y coordinate is 3 over 2. Okay. Second one, let's sub x equals 150 degrees into y. Okay, so it's going to be y equals 3 times sine 150. Don't reach for the calculator because again that is non-calculator. We've done sine 150, right? We know how to do that. Let's try it. This is getting back to our 4 quadrants in one of our early lessons on trig from higher maths, which is the exact value stuff in the cast diagram. Okay, 150 degrees lies in here. We're in the sine quadrant. Sine 150, sine is positive in the sine quadrant. The acute angle is 30 degrees, so that is 1/2. 3 times 1/2, we've already done it. Up there, 3 over 2 again. So point of intersection 2 is 30 degrees, rather 150 degrees, 3 over 2, and that's my 2 points of intersection. Now what we're doing here then is we're applying trig equations into finding the points in intersection of their associated trig curves. That's example 1, let's try an example 2. Okay, we're going to find the point of intersection between, points of intersection between that curve and this curve. Okay, now I'm told first of all that the blue one is a cosine curve and it's of the form a cos bx, and the red one is also cosine curve a cos bx. Okay, so both got to 1 down to -1. So amplitude for both then is 1, so it's 1 cos of the blue one, there's 1, 2 complete curves in 360, 1 cos 2x, and for the red one, it's 1 curve, so it's 1 cos 1x. Okay, find the points of intersection then. I'm going to make y equal to y. 1 cos 2x, I can just write that as cos 2x is equal to 1 cos x. I can just write that as cos x. Cos 2x equals cos x. Cos 2x minus cos x is equal to 0. So I've now got to think about my expansions for cos 2x. 2 cos squared x minus 1. 1 minus 2 sine squared x. Or cos squared x minus sine squared x, which is the one that I rarely use, so really it's a choice between here and here. Now the previous note told you in video, if you get cos 2x, that double angle, and cos x also appears in the question, you must use 2 cos squared x minus 1, so that is a straight substitution. 2 cos squared x minus 1 minus cos x is equal to 0. Let's tidy that up. Put it in a more familiar order. 2 cos squared x minus cos x minus 1 equals 0. Okay, next move, let's take that to the side. We're going to liken 2 cos squared x minus cos x minus 1 equals 0 to something a bit more familiar. We're going to liken it to 2x squared minus x minus 1 equals 0. That's now about a national 5 factorising of a quadratic equation. Two numbers that multiply give minus 2 and add together to give minus 1. Okay, so what's that going to be then? That's two numbers, that's minus 2 and 1. Drop 2x in there, drop 2x in there. Common factor of 2 brings me down to x minus 1. Bracket 2x plus 1. Okay, x minus 1. Cos x minus 1. 2x plus 1. 2 cos x plus 1. And that's equal to 0. Okay. That times that equals 0, which means that could be 0 or that could be 0. So let's explore both options, line down the page. Okay, cos x minus 1 equals 0 and 2 cos x plus 1 is equal to 0. Cos x equals 1, cast diagram, and they're all in the cosine quadrant. X equals cos inverse 1, and when's cosine curve equal to 1, 0, that's my all quadrant solution. I'm also in the cosine quadrant. Okay, so it's 360, take away 0, that's 360. Over here, 2 cos x equals minus 1, cos x equals minus 1 over 2, make it positive, cos x is equal to 1 over 2, cast diagram. Okay, for cos I would normally look non-cos, but I've changed it from negative to positive. I'm going to look in sine and tan. X equals cos inverse 1/2. When's the cosine curve equal to 1/2? That's one of my exact values, 60 degrees. As I can see, that's my all quadrant result, but I'm not in all quadrant, therefore that is not a solution. Score it out, but I'm in the sine quadrant. 180 take away 60, 120 degrees, and the tan quadrant 180 plus 60, 240 degrees. Okay, next I'm going to sub these four results, 0, 120, 240, 360, into one of the equations for y. Just choose one, it doesn't matter which one. The easiest one is cos x. So this is on no calculator. So cos of 0, that's equal to 1. So there's my first point intersection 1. Okay, 0, 1. Let's go after the second one, point intersection 2. Well, it's going to be y equals cos 120. Okay, back to my earlier work. cos 120. I'm in the sine quadrant, so that's going to be negative for cos, and the acute angle then is 60 degrees, so that's minus 1/2. So point intersection 2 then is going to be 120 minus 1/2. It's going to be a bit cluttered. Let me just enlarge that a bit. 120 minus 1/2. Okay. Third one. Going to sub in 240. So it's going to be y equals cos 240. Okay, so 0, 90, 180, 240. I'm in the tan quadrant, so cos is negative. Acute angle is 60 degrees. Okay, that's minus 1/2 again from exact values. So point intersection 3. 240 minus 1/2. Okay, finally, let's go for subbing in 360. Y equals cos 360. And y is equal to, what's back to 1. That's one of the exact values. Cos 360 is equal to 1, if I think about the cosine curve. 0, 90, 180, 270, back to 360. That's 1. Okay, so that'll give me point intersection 4, which is 361. And there are my 4 points of intersection. Final answer.